Hi guys, in this video we're going to look at ionic equations for acid-base reactions. So ionic equations are just simplified equations that show us the ions that are directly involved in that reaction. So we've got two example reactions here between strong acids and strong alkalis. So in our first example, we have sodium hydroxide reacting with hydrochloric acid. So notice I've included state symbols AQ, so lowercase small aq in brackets means in aqueous solution. So these are ionic compounds dissolved in water. And when an ionic compound dissolves in water, it breaks up or dissociates into its ions. So these two react and we form sodium chloride, so the first bit of the alkali and the last bit of the acid, and water, so the OH from the alkali and the H from the acid. Now the salt is in aqueous solution, it's ionic, it's made from positive and negative ions, but water is in liquid form, so it's not an ionic compound, so that does not dissociate or break up into its ions. So to get the ionic equation, what we do is we have to show each of the substances in aqueous solution breaking up into their ions, and the next thing is we cancel things that appear on both sides of the arrow. So the sodium ion appears on the left and it also appears on the right, so we'll cancel that out. The chloride does as well. And what are we left with? OH minus plus H plus gives water. And that is our ionic equation. So that tells us that the reaction is a neutralization reaction. And the things that are directly involved in the reaction are the H plus from the acid, the OH minus from the alkali. And these combine to produce water. In our next example, we've got sodium hydroxide again, so the same alkali, and this time we've got a different strong acid, sulfuric acid. These combine to produce a salt, sodium sulfate, and water, and we've balanced this time. So we do the same thing again. Each of the substances in aqueous solution, so the ionic substances, break up into their ions when dissolved in water. So sodium hydroxide, we've got two sodiums on the left and we've got two sodiums on the right from the sodium sulfate salt, and we've got one sulfate on the left from the sulfuric acid and one on the right from the salt. And again we're left with OH minus, H plus, giving water. So notice we've got two OH minus and two H plus. So we can't put the little 2 after the H, that was just there to balance out the ions because sulfate's a 2 minus and hydrogen's a 1 plus. So the 2 has to go in front. So here is our ionic equation. And the things that we cancelled out, these are called spectator ions. So spectator ions are just there, sort of swimming around in the solution, but they do not directly participate in a reaction.